So, you know why, you guys have all taken the Networking 1 class. You may have gone online and looked at a subnetting video, right? Maybe you looked at a book and you looked up subnetting. And a lot of you might not understand subnetting still, even after you looked at a video, spent time, paid attention in class and theory, and you still don't get subnetting. The reason you don't understand subnetting, this is the only reason why you don't understand subnetting, it always comes down to this one piece of information that is the key to unlocking subnetting, and that's the binary values of a byte. Starting from the high order bit and working down to the low order bit. That is the highest value bit to the lowest value bit. That's part one of understanding subnetting. It's like the key that helps you decode subnetting. The other piece, the other reason why you don't know how to subnet is you need to be able to represent in decimal a subnet mask. Right now, to do that, you have to add the binary positions from the high order bit down to the lower order bit. Because what you probably know is that the subnet, you borrow bits from the host portion and you reallocate them to the network portion. So if I'm borrowing from the host portion, then I'm going from the high order bits, the 128, and working my other way back, all right? And so since I'm going that way, I'm going to say, okay, I'm going to take these two bits, the 128 bit and the 64 bit. I'm going to use those two bits. If I want to represent that in decimal, what's 128 plus 64? 192. And so that's what I would show. So for example, if I had a class C and I was borrowing 2 bits, it'd be 255, 255, 255, that's class C. And then 2 more bits would be 192, right? So the bottom line is, the reason you might not be able to subnet right now, even though you spent a lot of time, is like, you must do this first, before you can even begin. So by next class, you should be able to memorize this chart. I mean, if you can, you're in trouble. And you don't even have to really make it a chart. I mean, just know the binary values, right? Just 8 bits, right? Just 8 bits. And you know the high order bits, they start off at, and it's really simple. It's 128, 64, 32, 16. Do you know why we do this? Why? Because a computer would see an IP address, right? Or a router would see an IP address as one long binary number. The only reason why we break this up in the 8 bits into 4 groupings is for people, for us to be able to understand and figure it out. The only reason why we do it this way is so we can actually do, quickly, subnetting in our own head. Right? That's the reason why it's written this way. Right? And that's the function. The computer doesn't need it, it's just for us. And this is what you write down to help us figure this out. And that is the 128, 64, 32. So I want you to write this down, because there's going to be an assumption that I'm going to make. And the assumption is going to be that this is either memorized, or you have it written down in front of you on a piece of paper that you can refer to until you memorize. So this is the byte binary positions, the value of each one of those binary positions. So the next thing, since you're borrowing bits, you know what happens when you subnet. You have the host portion over here, and you have the network portion over here. And what you're doing is you have this line that moves in this direction. So you're taking from the host and making them network bits. Right? And so, what you're doing then is you're going to represent this network in a network mask. And this network mask, you see in 255, right? That's all the bits turned on. Well, if I needed just to have 2 more bits from what was originally class C, then I would be using a 128-bit and a 64-bit. So ultimately, you want to be able to add them together. You should have this memorized. So 192, and then 224, 240, 248, 252. You know I'm going to end up at 255, right? 254, 255. Right? So that's the reason why we have these numbers. If I was going to borrow 1 bit, right, I was just moving that line over, just 1 more bit was being reallocated, then my mask would be 128. So it would be 255, 255 is a class C 128. Right? That's crucial. You have to memorize this. Now another element, this is what I'm going to do right now is just write down the elements that you need to subnet. Another element that you need to subnet is you need to decide how many bits you need to borrow, and then you have to decide the how do I want to put it, the number of bits you need to borrow to describe the number of networks or hosts that you might need. For example, since we're subnetting, we're making subnetworks. So you have to figure out how many bits do I need to borrow to describe the number of subnetworks. Right? Now, since this is binary and it's on-off, right, it's going to be to the power of 2. This is a little formula that you use. It's actually pretty simple. It's just a reflection of the power to 2, the fact that it's binary. So it's going to be 2 to the power of, 2 to the power of n, all right? And so it's going to be 2 by the power of number of bits that are borrowed. 2 to the power of number of bits borrowed. For example, if I borrow 3 bits, then how many subnetworks can I represent? If I borrow 4 bits, how many subnetworks now do I have a result of borrowing those bits? Right? Now it can be the other way too. It can be if I have 5 bits left over after I borrow 3 bits, then how many host networks are represented? 2 to the n works well either way. At one time you had to do 2 to the power n minus 2 because, I'll explain better in another class, because the broadcast and the network would confuse with the original networks as being broken up into pieces. That is, you have a network and you break it into subnetworks, the router would be confused between the network from the original and the network of the first usable network. It would get confused. Or the broadcast, the last usable, and the broadcast of the networks has been broken up into pieces. I'll explain and show that better in the next class. But 2 to the n, that's what you need to know. Right? Now, to use this, you're going to have to know the different powers that you have. Right? So, for example, 2 to the power of 3. Time to go to class.
Yeah.
2 to the power of 3. Right? So what's 2 to the power of 3? 8. Right? So you have to memorize up to 2 to the power of 8 would be good. 2 to the power of 8. Now, luckily, you have even more if you go higher. But luckily, if you memorize this, did you notice that the powers of 2 are also written here as well? Did you notice that? For example, if I were to put a 0 here and start going like this, 1, 2, 3, 4, 5, 6, 7. But those are actually the powers of 2 right there. For example, 2 to the power of 4 is 16. 2 to the power of 5 is 32. See what I'm saying? However, probably, if you just memorize this, and then you should get into the habit of saying, and just memorizing that the 4 is underneath 16, or just memorize 2 to the power of 4. You want to picture it in your mind, right? But you should memorize it. 2 to the power of 5 is 32. Memorize that. So once you have that memorized, the next element to subnetting is to find the number of networks and to figure out the network ranges. To figure out the network ranges, it's always the same. It's going to be the last bit borrowed. And I'll show you why in a future class, why it's always the last bit borrowed. But it's always the last bit borrowed. So the last bit borrowed. For example, if I were to borrow 3 bits, now first off, if I want to borrow 3 bits, how many new networks would I make if I borrowed 3 bits? Okay, so 2 to the power of 3 is, what is 2 to the power of 3? 8. Right? 2 to the power of 3 is 8. So that means that now I'm going to make 8 subnetworks. And what will those 8 subnetworks be? Right? Well, you use a counting number. The counting number will be the last bit that I borrowed. So if I'm going from the high order bit to the lower order bit, or going from the left to the right, I'm going to borrow the 128 binary position, the 64 binary position, and the 32-bit binary, 32 binary position, right? And so what my counting number is going to be, start off at 0, it's going to be 0, 32, 64, what's 64 to 32? 96. And what's the next one? What is it? 128? Yeah. And the next one is, what is that? 160? And then 192. It should fit in, so yeah, it does end up being 192. And then the next one is 224. And then the one after that is, yeah, so it can't go to 256. So these are your networks. So you've got 1, 2, 3, 4, 5, 6, 7, 8. Those are my 8 networks. 0 can be counted. Now in the past you wouldn't be able to use 0, but that was long in the past. We've got modern equipment which can do the same thing we're doing in effect. Right, so you don't have to remove the first network. So that's how it's done, really. The next part is to figure out what are the IP addresses in that range. So once you found your networks, then you just go through a series of calculations to work it out. All right? So, you guys have any questions? So it's 2 to the n to represent the number of bits. You know, how many bits do you need to get this number in decimal? Right? How many bits you need to get this in decimal? All right, so for example, we will do, let's say I need to make, we'll make 4 subnetworks. We'll just make 4 subnetworks, right? And originally our IP address is going to be cat, dog, fly, 0. That's my network, cat, dog, fly. It doesn't really matter, does it? Cat, dog, fly. Cat, dog, fly is not going to change. The only part that's going to change is this where the 0 is, right? And that's another point too. Where do I apply my counting number? In another class, we'll make sure that you understand where do I apply that counting number that I use, right? And just to remember, maybe you should write this down, you apply your counting number where it is not 255 or 0, right? So you apply your counting number where it's any one of these. That's where you count, not 255 or 0. That's where you count. Anyways, in this case we have cat, dog, fly, and we have only 8 bits that are available to work with, and we want to make 4 networks. So how many bits do we want to borrow to make 4 subnetworks? 2 to the power of 2 to make 4. So in that case, we're going to borrow the 128-bit, the 64-bit, and the 64-bit. The 64 is going to be our counting number. Now our first network will be cat, dog, fly, 0, because that's a valid network nowadays. Right? Now our next network would be cat, dog, fly, 64, and then cat, dog, fly, 128, and cat, dog, fly. What's 128 and 64?
192.
What is it?
192.
192. And then if I add 64 to that, I get 256, I imagine. Yeah, 256. So those are our networks, right? Now the next part, and I'm not going to write cat, dog, fly over and over again, but the next part is you add 1 to your network to find your first usable IP address. You add 1. Right? And then it's easier to do this, but you subtract 1 from next network to get the broadcast. Then you subtract 1 from your broadcast to get your last usable IP address. So it becomes +1, -1, and then -1, right? And that gives you your network range. So our first one's going to be 1, all right? And here this will be 65. I'll do this column first. This is 129, and this is 193. First usable IP address, that is cat, dog, fly 1, cat, dog, fly 65, cat, dog, fly 129, cat, dog, fly 193. I could have said A, B, C, but it's more fun saying cat, dog, fly. Whatever random thing that comes up in my head while I'm doing a problem. And so what you do is to find the broadcast, subtract 1 from the next network. So on this first row here, my next network is going to end in 64. So this would be 63. The next row, my next network is 128. Sorry, 128. So I'm going to make it 127 here. And the next row, I got 192. So we can make this 191. And then on this final row, it's going to be 255 because all the bits would have been taken up. And I'll show you this, and I'll show this all to you in binary in a future class, but I just want you to see the process. And this is the process. All right, and then you subtract 1 from that. So you get 62, 126, 190, and 254. And so you have cat, dog, fly 0, cat, dog, fly 64, cat, dog, fly 128, cat, dog, fly 192. The first usable IP address for cat, dog, fly 0 is 1, and the last usable IP address is 62, and then your broadcast is 63. Right? And that's it. That's all there is to it. So if I were to borrow 3 bits instead, 64, you essentially just break these ranges up into smaller pieces. I mean, if you can almost imagine like a box being broken up into smaller pieces. Right? And it's, you can, in a way, you should be able to do it in your head. Or with 16 is your counting number, 8 your counting number. Right? And it's all the same. And the only difference between this, if it was a class, let's say it was a class B, then I'd have cat, dog, 0, 0. And where would I count at? Where would I do my counting? If it was a class B, right, that I was working with. Well, I would count where fly is now. But my mask would have been, by the way, what is my mask? What's my new mask? You guys know what my new mask would be?
Cat, dog.
Well, I mean my subnet mask. Originally it's 255, 255, 255, and I borrowed 2 more bits. What's my mask? 192. Yeah, so 255, 255, 255, 192. If this was a class B, then originally it'd be 255, 255, 192. And so where do I count? I count, where do I apply my counting number? I apply where it's not 0 or 255. That is where my mask is set to 192. You see what I mean? That's the process. And it doesn't matter. This is a class A. What's the difference? You're going to count where it's not 0 or 255, and your 192 would actually be where dog is now. Right? You follow? And that's it. That's how you subnet, right? That's subnetting when you stay within a byte. Now, when you go over a byte, it's a little bit more complex, but that's for another class. But let's say, for example, here I'm borrowing 2 bits, right? It's all the same, you know, where do I count? But what if I borrow 9 bits? What if I borrow 10 bits? Well, what do I do there? It's actually the same thing. It just looks a little bit different. And I'm going to show you how to do that probably with the 3rd classes. Because I want to show you how this all works in binary first, before I show you what happens when you borrow more than 8 bits. Right? Because it makes really a lot of sense when you see what's happening in binary. Right? So the 3rd time I explain subnetting to you, I'll show you what happens when you borrow more bits. All right? Any questions? Okay, good. So we'll try some problems, and I'll put this on the internet. Stop recording.